So here's what happens in this problem. We got this guy, they're on ice skates. So I'm going to call this first guy M1. His mass is 75. He cruises in with a velocity of 10 meters per second and hits this guy here who's standing at rest with no velocity at all. So this is what we have before the collision. Now, the problem tells us the two skaters move off as a unit, which means they stick together. They share the same final velocity. So we add the masses, 75 and 75. It tells us, I missed this the first time. You know what I did? I actually solved for the mass of the second guy. You can do that with the data. You know, if they didn't tell us that, if they did not say equal mass, you could figure out what the mass of the guy, of the second guy had to be. So I solved it, and I was like, wait a minute. So anyway. All right, so after the collision, they stick together and move off with a final velocity of 5 meters per second. The question is, if the impact time is 0.1 seconds, so the time of the collision is 0.1 seconds, does a bone break if the maximum force is 4,500 newtons? So what we're going to do is we're going to calculate the force of the collision and then compare it to this number. If the force of the collision is less than that, there's no broken bone. If the force that we get is greater than that, then there will be a broken bone. Okay? So how do we find the force? Well, look, we're either going to focus on this guy or that guy. It doesn't matter. You'll get the same answer no matter which guy you focus on. Because what does Newton's third law tell us? Every force has a equal and opposite force. So look, when guy number one hits guy number two, there's going to be a force that way, right, on guy number two. But simultaneously, there's going to be a force on guy number one the other way. Does that make sense? So when guy number one hits guy number two experiences a force to the right. Guy number one experiences a force to the left. What do we know about those two forces? They are equal and opposite. So we can solve for this force of impact focusing on either guy. Which guy should we focus on? It don't matter. Should we focus on M2?
Or the first one.
Well, we got to pick one. You'll get the same answer either way. Let's just focus on guy number two. So focusing on guy number two, the equation we could use here is F net equals change of momentum over time. And I showed you a while back that that's the same thing as MA. That simplifies to mass times acceleration, which you could do. If I gave this to you on the quiz, I'd accept that. If you used F equals MA, that's fine. Okay, so focusing on guy number two, well, what can we say about change of momentum? Well, what's momentum? Momentum is mass times velocity. So what will change of momentum be? Mass times change of velocity. So it's going to be mass times change of velocity over time. Okay, what's the mass of guy number two? We're focusing on guy number two.
75.
His mass is 75. What is his change in velocity? He goes from 0 to 5. So his change of velocity is 5. And then how much time did that take? 0.1. And again, notice, what's this? What's change of velocity over time? That's your acceleration. Hello, Mr. Engel. Speaking of physics, Mr. Engel, I'm recording a video right now. Would you like to say anything? This is going.
Let's go down to all you physics students out there. This next one is about ice skaters.
Mr. Engel, he's sick today, but that voice, and when I say sick, I mean, I don't mean like sick. I mean like he's really sick. But I mean, in general, you're pretty sick.
Yeah, but I like being sick sometimes because the voice comes out.
Yeah. Do you guys use that phrase anymore? That's sick. Kids used to always say that. Be like, if something was cool, they'd say, "Oh man, that's sick." Do you guys say that anymore? Do you remember that? Okay. Shh. All right. Shh. Let's finish this off. So, The net force, when you calculate this, the net force on guy number 2 came out to be 3,750. Does he break a bone? Nope, because bones break apparently at 4,500. Okay? Now, on tomorrow's quiz, I'm going to ask you to calculate the energy lost in the collision. And it's not that hard. If you lose anything, I don't care if it's marbles or money or what else could you lose? Brain cells, huh? Keys. If you lose anything, you got to know 2 things to find out how much you lost. You need to know how much did you start with, how much did you end with. If you know those 2 things, you can figure out how much you lost. So here we're going to calculate the kinetic energy lost in the collision. All right, so let's look at it before the collision and then after the collision. All right, which object has kinetic energy before the collision? Guy number 1. Guy number 2 is not moving. Okay, so this will be pretty easy. So we're going to go 1/2 m, which is 75, v squared, his velocity is 10. So the kinetic energy before the collision is 3,750 joules. Now, let's calculate how much kinetic energy we have after the collision. So we go 1/2. What's the mass after the collision? 150, because they combine together, right? The 2 become 1. Okay, 150. And then the velocity after the collision is 5. You calculate this out. Kinetic final is 750. We started with this much. We end with that much. How much did we lose in the collision? 3,000 joules of mechanical energy lost, which in other words, kinetic energy. The mechanical energy here is kinetic. All right? Okay.